Okay, so let's start the session. In this session, I want to cover some very basic ideas from Python. And this will be just basic types, constructs, and iterations, and how to define a function. There's much more to these things than I'm going to tell you, but I think it's enough for us to then to start doing some programming. Okay, so let's see. Okay, so I hope that everyone can see this Python notebook, which is titled lec3a.
Yeah,
Well,
yes, sir.
yes. Please repeat your question.
I was just saying that I can see it, sir.
Okay. All right. Okay, so one thing we're going to need to do a lot is to print output. So unsurprisingly, we have a print command. So you say print. Your notebook will highlight important words like print and other things that it understands as commands in green, at least on my notebook. And then you put a string in quotation marks of if what you're printing is a string, put it in quotation marks. And then, and then once you've got your notebook running and you type something like this in, you'll hit run over here and it'll do what you said. If you wanted to say something else, you decide, oh, that's not what I wanted to say. I didn't want to say hello world. I want to say go away, right? Then you go back, and if you're satisfied with that code, then you'll hit run on your notebook and it will change. Okay, as I'm going along, wherever anything doesn't make sense, please speak up, okay? But that's kind of rude, so let's change that back to hello world. So first, let me ask you, will everybody be able to, or has everyone, does everyone have Python installed on their machines? Right, would anyone need any help getting it installed? Okay. How about
Professor,
notebook?
for the Juniper notebooks, should we install it by itself or should we just get the Anaconda package?
I think if you get the Anaconda, I've used the Anaconda package. If you use that, that should be fine. Just as long as we're both using Python 3, okay?
All right, sir. Thank you.
Yeah. Okay. Now, here in the, yeah, there's a question?
Yes, sir. Sir, also, can we use Google Colab for this course?
I think so, yeah.
Right.
But what I mean, provided that you can turn in notebooks for assignments.
Yeah, sir. We can do that.
Okay, so as long as you can turn in notebooks for assignments, then that's fine. The exact how you want to work it on your system is your issue. That's fine. And
Okay.
if people need help with installations of either Python 3 or with a notebook, then you let me know and we'll have our computer guy maybe do a session on that, okay? So now if we want to have some, we think that we might want to change what we're printing and then not have to go back and change anything else, then I can say that let S be, why did I put that in brackets? Anyways, let S be this string, and it will print that string. And if I change the string somehow, and I ask it to print, then it will print what I've changed. Okay. So there we've defined what we call a string variable. Now let's say we want to define an integer variable. We say that a is equal to 5. Now in some languages you would want to say something like int a is equal to 5. But here a is assigned then by the equal sign to something which is obviously an integer. And so Python doesn't require you to say that a will have to be an integer. You've made it an integer. Okay. And then we notice something else about the print command, that you can print different things. So you can print, here you've got a string, in quotations you've got a string a equals. So it's printing that string followed by a, which should be the value that's been assigned to the integer variable a. So you can print a is equal to 5. Now, if I change a, I set equal to an integer, but now I can set it to be something else. I can set it to be equal to this string. I've used the string Jabberwockian nonsense. But whatever, I could set it equal to a string now. Notice also that instead of using double quotations, I've used single quotations. Okay, so whether you're using double quotes or whether you're using single quotes, you should be okay, provided that you're consistent for a particular string. So then we can print that a, whatever you want to put. You say print, you have a brackets, open and close brackets, whatever you're going to print, put that inside of between the two brackets, and you can print it. Okay, now let's do a little bit of arithmetic. So I'll set x equal to 5, and I'll set y is equal to 10. Now, if I want to set, if I want to add the two, so it's what we would expect. We say result is equal to x plus y, and then I can print the string x plus y is equal to, and I can also print the result. And the result is, as I found. If I wanted to change it, and once, if I go back and I change it, then where I found the result, well, I'll have to run that again with the new value. And so then that updates my result. Okay. Now, if I want to subtract, well, there's the subtraction operator. So that's fine. There's nothing. And multiplication is represented by the asterisk or the star symbol. And we get what we expect. Okay, now division. What happens? So right now, Python understands x as an integer and y as an integer. So when I divide x by y, what should I get? And I think that what you got actually changed between the various Python 2s and Python 3. So this is why I'm asking all of you to use Python 3 in case there's something that's changed. We don't want to be coming up with different results for the same code. Okay, so everybody please use Python 3. Okay, and now, okay, so what's happened? X was an integer, y was an integer. It understood that x divided by y will not be an integer, and it promoted both of them to floats, floating numbers. And then it gave me the correct result as if they were floating numbers. Okay. Now, there's another division, which is floor division, and floor division means basically that you are going to get, the result that you're going to get is going to be the closest integer less than or equal to to the result. Okay? So I had x divided by some number which is bigger than x. The integer part of that you would expect to be 0, right? So the integer which was closest to the result but less than or equal to the result was 0. Something that's related is the remainder, right? So when you take x and you divide by y, as if we're doing long division like we did in primary school, you know, we got some number, the quotient, and then we said this is the remainder. So using the percentage sign x, percentage sign y, that will give you the remainder of x divided by y for x and y integers. Okay. All right, exponents. So if I have x and I want to raise it to the power y, the way you do it is the way you represent that exponentiation operation is you use double asterisk or double star. Okay? So if you take x and you raise it to the power y, then you get some huge number, right? Okay. Now, some other languages would use x caret y for x to the power y. Okay? But if we do that, we get something very different. So that's not what that means. Okay? So if you want to use exponents, that's use the double star or the double asterisk, right? Not the caret sign. Okay, so that isn't what we want. Okay, assignment operators. Well, you already saw an assignment operator. That's the equal sign, right? Set x equal to 5, set y equal to 10, set k equal to 3 over here, okay? Now, there's another one. Yes? Sorry, I didn't get that.
Sorry, sir. There's nothing.
Okay. All right. Now, if you wanted to set x equal to x plus k, what you do is you can use this. X plus equals k is the same as setting x equal to the old value of x, the value of x that you already have, plus k. So you can write x plus equals k. And if you do that, then you get, right, 5 plus 3 is 8. Okay? Now, if you wanted to set x should be your old value of x times k, right? You can either write x equals x star k, or you can write x star equals k. That's the same thing. Okay, and if we do that, right, remember x was updated to 8, so 8 times 3 was 24. Okay, and now if you want to divide x by k, so you want to set x equal to x divided by k, you can either write x equals x slash k, or you can write x slash equals k. And you should get 8, right? And what was happening there, you were taking 24 and you were dividing by 3. So that means you were multiplying by the reciprocal of 3. So everything got promoted to a float. So the result is 8.0. Okay. Any questions so far? I mean, if you're used to C++ programming, I've noticed people use this notation a lot. I'm an old Fortran programmer, so I tend not to use that. But anyways, you should know both notations because you should be able to read read other people's code, right? Okay, so if there's a common notation, you should know how to use it or understand it. Okay, any questions up until now? Okay. Another thing we want to be able to do is we want it to be able to take input from a user. So you have a code, and the code is, what it does is it takes in a string, some sentence, and maybe it prints it backwards or something, right? So you have to be able to able to input. A less silly example would be you have to be able to take the person's ID number or password or something like that. So you need to be able to take input. Okay, so this is an example here of how you can take input from a user. Okay, so you would say input string equals input, and then in brackets, whatever you want to send, whatever you want the user to see. Okay, so I want the user to see a message like, enter your password. Okay, so I will say input, enter your password, and that will give me some input string. And well, I'm going to set input string equal to that so that I can use it later on. Okay, and then we'll say print your password is input string to check what the person had entered. So if I run this, what does it do? It says enter your password, and it gives me a space in which I can enter some input. Okay. So let's say my password is XYZ. Then I hit enter. And now, right, so XYZ is now input string, and I can manipulate. I have something that I can manipulate as I like. Is that okay? All right. Now, for comments, I can do something like this. I can say X equals 5, and this is a comment about X. So I put in a hash mark or a pound symbol, and there's a comment, right? It's processed this without any problem. So it processed X, the assignment X is equal to 5, and then everything that came after that hash symbol, it ignored. Okay, so that's just for my readability. Now, if I wanted to write multi-line comments, I could either write a hash symbol before every line, but that would get tedious. Okay, so what I can do instead is I can put either triple single quotes or triple double quotes at the beginning and the end, and then I can write myself long multi-line comments. There's a question? Okay. I can write these long multi-line comments, and they will not be processed by, nothing will happen. It won't affect the flow of the code or anything. Okay, so either triple double quotes or triple single quotes for multi-line comments. Okay. Are we okay so far? All right. Okay. So let me say something about types. Okay. So I let S equal a string hello. I set it equal to the string hello. I set a equal to an integer 5, and I set b equal to a floating point number 6.0. Okay. Now I can ask what the type of any variable is. Okay. So sometimes, you know, you have a function, and you think that the function is written correctly, it behaves properly, but something is going wrong when you use that function, right? So quite often the problem is that the function is expecting an inputs of certain types, and you are giving it inputs of some different types. So you want to be able to check the type of your various variables that you're going to feed into that function. Okay? So I said, well, we know that S is a string, so if I ask it type of S, then it tells me that it's a string, str. If I ask for the type of A, well, A was an integer, so it tells me int. And if I ask for the type of B, then B was a floating point number, and it says that it tells me that it's a float. Okay? So if I've forgotten, or if I'm dubious about what the type of a particular variable is, then I can always inquire using type. Okay. Now, sometimes types need to change. So we saw before, we were dividing an integer by an integer, and the result is not an integer. And all by itself, it converted the types from int to float. Okay. So sometimes it can do this itself. So here, if I want to add a plus b, a is an int and b is a float. So in order to not lose anything, remember we talked about how we store things. This is related to that. So in order not to lose anything, what it does is it will, if I want to add a to b, it will promote a to a float and then add the two of them together as if they were both floating point numbers. So if I say result equals a plus b, so I'm going to print a, b in the result and ask for the type of the result. Oops, what happened? Okay, sorry, no, this, right. If I want to, what it will say is a was 5, b was 6, the result is, why? Okay, why did it do that? I think I've got some old code here which is messing things up. So let me just run that. Okay, right, all right. So I had a, which is an integer. I had b, which was a float. It added them together, and it gave me a result, which is a float. And that's because it, in the background, without my asking it to, it promoted a from an integer to a float. So that's implicit type conversion. Okay, this will fail, right? Because here I made a an integer, I made b a string, and it doesn't know how to add these two things together. It doesn't know how to add an int and a string together. Okay, and it doesn't know to promote, to change 6 from a string to 6 a float or a integer. Okay, so if I have something like that, then I'll have to explicitly tell it what to do. Okay, so a is 5, b is 6. Maybe I got that b from an input. Remember we were talking about input your password and so on. So I might have asked it to input an integer, and that's what I'm calling b. Except when I took that input, what I got was a string. And then that string should be converted somewhere. It should either be converted to an int or a float if I'm going to do arithmetic with it. So let's say that the result is a plus float of b means that now I'm explicitly converting b to a float. Okay? So now if I add things together, then if I add those two things together, a has to be implicitly converted to a float. We add the two floats together, and we get 11. Okay. Yeah, there's a question.
Yes, sir. Sir, so if we are taking input from someone, from a random user, what if they accidentally enter 6a instead of entering 6? So when we convert it to a float, how would that be treated?
Okay, so let's say you want someone to enter a number, and they enter a number that's a string, and then that can be converted. If you want someone to enter a number, and then they enter something, and that's a string, but it's a string that cannot be converted into a number, then you're going to get an error.
Oh, all right. Thank you.
Sir, if you were to input a character, would it just take its ASCII number and treat it as an integer?
Oh, yeah, okay, so sometimes it might do something weird with a character. I suspect you'll get an error, but why don't you try it and see what happens.
All right, thank you.
Yeah. Okay, so now if say in Fortran we have like arrays of real numbers or floating numbers, right? Floating point numbers. Python has a number of constructs which you can think of as lists or sequences. So it's got something called a range. It's got something called lists. It's got something called tuples. And you can even construct your own types if you want, of ways of putting lots of things together. The way we put together a vector or a matrix, a whole bunch of things are associated in some way. Okay? So one of the ways it does this is by something called a list. Okay? So one useful list is the empty list. Okay? This is the list with nothing in it. And the way you define a list, one way you would define a list is you would use square brackets, and then you would put whatever you want in your list, separated by commas. You would write those things out, right, between square brackets, and that would define a list. So if you say that my list, you're going to set it equal to, and in between square brackets you've got nothing, then you've got an empty list. But since you can append things to lists and delete things from lists, it's useful to have an empty list around, okay, that you can do things with, okay, like append elements to. Okay, so there's an empty list. My list is an empty list. If you ask it to print what my list is, it gives you in square brackets to show that you're talking about a list, and there's nothing in the list. Okay. All right, let's have another list. I'm going to say that my list consists of the numbers 1.2, 1.3, 1.4, and you put them in square brackets, and that means that it's a list. If you put them in round brackets, it'll be something else. So put them in square brackets, and you've got a list, right? So you print my list. Now we can print it, and it gives you in square brackets everything that you had said was in the list. Now, here in this example, I used all floating point numbers, but there's no reason why. I mean, you can have a list with with elements that have different types. So you might have, for example, have a list of things, and then you would have a string which would explain what these elements in this list are, right? So you'd have a list of temperatures, and then you might have a string saying, this is a list of temperatures, just to remind you that this is what you're talking about. Okay, so here, let's now set my list equal to, it's a list, I know it's a list because it's in square brackets. And then the first element is the integer 1, the second element is the integer 2.0, and the third element is the string, the winter of our discontent. Okay, so I run that, and it seems perfectly fine. And now if I print the list, if I say print my list, it'll give me the list, everything in it, and it will give me this between square brackets to show that this is a list that we're talking about. Now, if we want to, now if we want to change things, then what do? We have to be able to refer to the individual elements of the list. Okay? So this is how we go about doing it. Or I'll show you. My list of 0. Okay, so Python starts its counting from 0. Okay? So there's a 0th element. I said first, second, and third element. But if I wasn't an old Fortran programmer, I would have said there's a 0th element, a first element, and a second element. Okay? So if I ask it to print the 0th element of my list, the first element of my list, and the second element of my list, right? Then that's how I do it. And again, it's a list, so you're using it, right? So my list, and then square bracket 0, square bracket 1, square bracket 2. And what do I get? Well, the first element, the 0th element was 1. The first element was 2.0. And the second element was the winter of our discontent, the string. Okay. Now, let's say I want to change that, right? So my list of 2, the second element in my list was the winter of our discontent. But I want to change it to something happier. I want to change it to sunlit uplands. Okay? So I just say, all right, I didn't like what was in my list of 2. Please change my list of 2. I want to set it equal to the string sunlit uplands. So I do that. And I run that cell. Okay. Now if I ask it to print the individual elements of the list, I get the first one wasn't, okay, sorry. The 0th element was not changed. The first element was not changed. And the second element was changed from the winter of our discontent to sunlit uplands. All right. So with lists, you can change the element. You can in fact append elements to a list, and you can delete elements, individual elements from a list. Okay. Is that okay?
Yes, sir.
Okay. So that's one way, one construct for having a sequence, which you can we can say. So one way of expressing that idea is to say that lists are mutable. I can change them. Okay. However, there's another construct which is called a tuple. And once you've constructed the tuple, you can't change it. So tuples are immutable. Okay. And with tuples, you do the defining using round brackets instead of square brackets. Okay. Let makes that a bit larger. Okay, so tuples are not mutable. So let me invent a tuple called animals. And what I'll do is in round brackets, I will put the strings horse, goat, and turtle, right? And let's run, so we have that. And then we print the tuple using the name of the tuple. And it prints it in round brackets to show that it is a tuple. Now, what's animals of 1? The 0th element is horse. The first element is goat, okay? So animals of 1 should give me goat, and it does. Okay, what should animals of -1 be? Yeah.
There is nothing on -1.
Oh, yeah, okay. So this, okay, so that's one way to think about it. And I think your way makes more sense. But the way Python does it, it says is, well, horse is 0. So if I move over in a circular fashion by 1, I will get turtle. Okay?
Oh, okay.
Right. Okay, so maybe for some reason we want to print our tuple backwards or something like that. So maybe
is this like a circular group?
Yeah, it's circular, right? So we horse, if horse was 0 and you move to the left and you don't
So
fall
I
out,
meant a cyclic group. We
it's
studied informal.
yeah, it's cyclic permutations, right? So if you do animals of 1, so if you do animals of -1, then you will get turtle. So if you want the last element, so this is the thing, it's a neat way of getting the last element of a tuple. You forgot how many elements there were in the tuple, let's say, right? So, you know, I have a tuple names, and it's the names of everyone in the batch, right? I forgot how many there were of that, right? So then I'll just say, okay, names of -1, that'll give me the last one, whatever that was.
Sir, you're not asking it to print the words. Why is it still printing them?
Yeah, I'm not sure. Right.
Oh, okay.
I guess it does some processing, so it's just spitting out what that processing is for some reason.
All right, okay.
Sir, I think in Python,
Yeah. Sorry, for some reason I can hear some people properly and not others. So I'm not getting what you're saying.
Sir, it's fine. I had a comment. I'll make it later.
Okay. All right. So the easy way of getting the last element of a tuple is just to say name of tuple -1. Okay. All right. 133, 134. Okay. Now, if I want to change element 2, so if I wanted to change turtle to topos theory, then it doesn't let me do that. Tuples are immutable. Once you've defined them, you're stuck with them. Okay, you cannot change it. Okay, so it spits an error at me. Right, tuple object does not support item assignment. Okay, all right. Right, and because I can't change anything, it's that tuple is as it was. Okay, I can delete a tuple. Okay, so del is the means delete. I can delete a tuple, no problem. And if I run that, then tuples, now this tuple animal should no longer exist. I can check that. I'll ask it to print tuples, and it just tells me there isn't anything called animals right? Why? Well, because I deleted it. So you can delete, you can create a tuple in your program. You can delete it at some point if you want to, but once you've created it, you cannot go and change in individual elements in the tuple. All right, so strings are another type of sequence. So we've had lists and we've had tuples. And another kind of sequence, a sequence of characters, is a string, right? So we can set greeting, we can set that equal to the string hello world, and we can ask it to print hello world. And like I said, greeting is a string, it's a sequence of characters. So I can ask it, what is the 7th character in the string greeting? That's greeting of 7. Remembering that you're starting from 0. We start our counting from 0 in Python. Okay. Okay. And if we do that, it turns out that, okay, so 1, 2, 3, 4, 5, 6, 7, 8. But we started from 0, so that would be 7. So 0 is the 7th character in greeting, and yeah, that's what it told us. Great. Okay, now what if we have a string? It's one of these really big strings, let's say, and we only wanted some portion of that string. Okay. So, yeah, there's this question.
Yes, sir. The question that you asked, can we use a colon? For instance, if I want the characters from 7 to 9, so I'll say 7 colon 9.
That's right. So if I wanted from 2 to 7, right? Then I run this. Sorry. Right. So I run this, and what this says is from 2 to 7, the characters are LLO space character W. And wait a second. Do you notice something? When I said greeting of 7, I got an O. And when I said 2 to 7, it stopped just before the O. Okay? So what does that mean? What's happening there?
Sir, it's printing numbers between 2 and 7.
Right, but it's starting at character 2. Okay, remember, we're starting from 0. So 0, 1, 2. So it starts from L, right? 3, 4, 5 is the space. 6, 7 is the O, but it's stopping at 6. Okay? We'll talk more about ranges in a bit, but just for now, 2 to 7, 2 colon 7 means start from character 2. Go up to character 7, not including 7. So including 2, but not, and then moving along up to 7, but not including 7. Okay? Now, there's a big, long discussion and definition of string manipulations. We're mostly going to be doing numerics, so we're not going to make a long song and dance out of string manipulations, but you have to be able to understand other people's code. So this is important, that this range 2 to 7, 2 colon 7 means starting from 2, including 2, up to 7, not including 7. Okay? All right. Okay, let's try and change the greeting. Let's try and change greeting of 7 was an O. I want to change it to a C. Let's try and do that. It says, no, you can't do that, right? Strings are also immutable. You cannot change individual characters in the string, which is a sequence of characters. Okay, so string object does not support item assignment is the way it describes that. All right. Okay, what if I want the strings to be a little bit extended? Okay, so the way we do it is we use triple quotes, either triple single quotes or triple double quotes. Here I've used triple double quotes. So if I write the phrase, welcome to my parlor, said the spider to the fly, I run that to get the assignment. And then if I ask a print, so the way I've written it there, that's the way it will output it. Okay. So if you have multi-line strings, then this is the way to do it. Don't use quotes, use triple quotes. Okay. Again, I doubt that we'll have much use for you. At least in this course, we only need to know the most basic things about strings. I know that CS students will be disappointed because they spend so much time on this sort of thing. Okay, you can also concatenate strings. I want to put strings together for some reason. So we can have a string 1, which is hello. We can have a string 2, which is hello world. And what I can do is I can have a string 3, and I can say string 1 plus a space plus string 2. That's what I'm calling string 3. And I can get hello world. So addition with strings doesn't mean some sort of arithmetic. It means concatenation. Okay. All right. Okay, back to ranges. We already saw this 2 to 7 that we saw previously with strings. That meant including 2, not including 7. Okay, so there's another type of sequence called a range. And so let's do a few examples. So my range is range of 3. Now that's a range. That's a particular type of construct. It's not a list. It's not a tuple. Right? There's another construction called a set. It's not a set either. There's another construction called a dictionary. It's not a dictionary either. It's its own thing, right? A range is something distinct from that. But what you can do is you can use type conversion, and you can say this range of 3, whatever that result is, it's a range, but I'm going to turn it into a list because that's easier for me to think about. So if I take range of 3, I turn it into a list. What list do I get? I get 0, 1, 2. So what it seems to have done is it seems to have implicitly started from 0 and gone up to 3, but not including 3. So that range consists of 0, 1, and 2. Is that okay?
Sir, is this range could be in floating points, means 0, 0.0, 1.0, 2.0?
Yeah, it could, but yeah. So what's happening here is there are some implicit things going on, right? So it's implicitly starting from 0, and it's implicitly increasing by 1. Okay, so that's why we've got this. But yeah, there are other ways. I'll show you a couple of other examples. Okay, so what if I want to start from 1? I don't like this Python business of assuming that we should be starting from 0. I want to start from 1. So I will say range 1, 3. And what that means is, well, let's turn it into a list and see what that means. Okay, so what it seems to mean is starting from 1, including 1, and going up to 3, but not including 3. And it seems to be implicitly increasing by 1 in each step. Is that okay? All right. Let's change the step here. Okay, so what if I wanted to go from 1 to 10? I want to list from 1 to 10 using this range. So what I do is I create a range from 1 to 11. That means start from 1, go to 11, not including 11, and implicitly increasing by 1. And then, so that should give me to 10. And that's what it does. If I change that into a list, I have a list of integers going from 1 to 10, not 1 to 11. Okay. Now, let's do a couple of more examples. This is the same thing. So this comma 1 means increase by 1, but that's actually what was happening implicitly anyways before. So if you're just going to increase by 1, you don't even need to write that. I think it's nice to be clear, right? So go from 1, go up to 11, don't include 11, and increase by 1 each time. Now if I change that, I say, okay, so there's the, change that into a list, I will get a list of numbers from increasing by 1 from 1 to 10. Is that okay? All right. Now, what if I don't want that? What if I don't want to go in steps of 1, but rather I would like to go in steps of 2? Okay, so then let's see what happens. If I say I'm starting from 1, going up to 11, not including 11, in steps of 2, I change that to a list and print the list. Then 1, 3, 5, 7, 9. The next one would be 11, but we said we wouldn't include 11. Okay. Now, going in steps of -1 could also be useful because I want a countdown of some kind. Okay. So range of 10, comma 0, comma -1. What should that do? And then I change that into a list. So what should that list look like?
So
8,
reverse
9,
count.
8, 7.
Yeah. So you go from 10 down to 0, not including 0, decreasing by 1. So I should go from 10, 9, 8 up to 1, I think. Yeah, and that's what I get. Okay. Are we okay so far?
Sir,
Yeah.
is range kind of loop, like a for loop or something like that?
Yeah, one thing to do is when you have a range, you can then use the for construct with that range to do things. Okay, so you can use a for with a list, you can use a for with a tuple, you can use a for with a range. Okay. Okay.
Sir.
So if else. So if else constructions. So there's a few things to point out here. Let's try this one. I'm going to make num equal to 2. I'm going to do a test to see whether num is positive or negative. So if num is greater than 0, okay, so this is the way it works. If there's some condition, colon, and then what follows after is to be done. If this condition is true, something is to be done. In this case, execute this print statement. And this should be tabbed over. So you should, if your notebooks kind of do a lot of the tabbing for you automatically, but if it doesn't do it, or if you're using some other kind of editor, then you have to hit, there should be a tab in front of this code which is to be executed. So if this condition colon, tab, the thing to be executed. For some reason, else if has been turned into elif in Python. I think probably it happens in Unix, so people do that. Okay, so else if, elif, let's read that as else if num is identically equal to 0, colon. Now, what code is to be executed? Hit the tab key if it isn't done automatically for you. And then the thing which is to be executed is a print statement. Now you could have a whole bunch of conditions, right? You could have elif some other condition, elif some other condition, elif some other condition. We don't need that here, but in principle you could have lots of those. Now finally, else, if you've done all of your conditions and you've passed through all of them without executing any code, now you have else, colon, and else is optional here, but here I've decided to use it. Else, colon, then tab, and then the code to be executed. Is that okay? All right. So now if we run that, this is a test to see whether num was positive or negative or 0, and it reports that it is positive. Okay. So while loops. So you use while, and that says keep doing this iteration. So now we're doing iterations, okay? So you keep doing some iteration, iterating some code over and over again, as long as the while condition, as long as some condition holds. Okay, so here's an example. N is equal to 6, prod for product is equal to 1, I is equal to 1, okay? Here's the condition. While I is less than or equal to n colon, that means everything which follows under the while, and each line has to be indented with a tab. You're going to execute this code which follows as long as this condition holds, that I is less than or equal to n colon. Now after the colon, in tabbed, each line tabbed, tell me what code you want to do. Okay, I want to multiply the product by I, and I want to increase I by 1. Now tab in the other direction to make sure now that you're out of the while loop. And now you're going to print the result, and this should calculate 6 factorial for you. So I say print 6 factorial is equal to whatever prod is, okay? And it's 720. Okay, so this is the while. It will keep executing until some condition is no longer met. And if you're sloppy, and it starts going on forever, then check to make sure that at some point the condition fails to be met, okay? All right. The for can be combined with a list, a tuple, a string, or a range, and it sort of goes through each element, okay? So range of 5, what does that give me? It gives me a range of numbers which are what?
0 to 4.
0 to 4. So for I in this range, I want you to print I. Okay? So what should it do? It should print each thing in that range. Okay? For I in some list, it would print each element of the list. For I in some string, it would print each character in the string. For I in the range, it will print each element in the range. And yeah, it does what we expect it to do. Okay. Okay, so here's another one. We have a bunch of numbers. We have that the sum, we'll set the sum equal to 0 to begin with. And for the value in this list of numbers, nums, colon, what do I want to do? It's just going to go through each one, call it val, and add val to sum. Okay, there are better ways of summing elements in a list. Okay, I'm just using it to show how the for allows you to go through each element of these sort of sequence types that there are. Okay, so if you do this, oops, if you do this, it will start, sum is 0, then it'll add the 1, then it'll add 2, then it'll add 3, then it'll add 4, then it'll add 5. You get up to 15. Okay. An example with a break. Okay, so if there's a break, what it will do is it will kick itself out of the for loop. Okay, so here's a string. It's got I'm calling each character C. So for C in this string, what do I want you to do? I want you to print C. And if C is ever W, then I want you to kick out of the loop. Okay, so if you do that, sorry, okay, right? So it went N-O-W, and then because C was W, the break said, okay, kick out of this for loop, and you're done. Okay, now with continue, so, right? For C is in the string, if C is W, then I want you to continue. I want you to go on to the next one without doing anything. Otherwise, I want you to print C. Okay? So what should it do? It should skip all the W's as it print. It goes through and it will skip all the W's. So now is the enter of our discontent. Okay. Okay, pass with a for loop. Okay, for C in the string, just pass. What that means is I know that there's a for loop that should come in here, and I'm going to write the code later. But for now, I just want you to not do anything. I just want you to go through, iterate through the sequence, but not executing anything. Okay, so it doesn't do anything. Defining a function. So use def. Def means def, then followed by the name of the function, and then in round brackets, all the inputs to the function. In this case, there are no inputs to the function, right? So when I call silly function, what I want you to do is to print, this is silly function, okay? And how do you call silly function? You just write the name of the function and its inputs. In this case, there are no inputs, so just an empty round brackets. So do this. This is silly function. Is that okay? All right. Now,
Yes,
if I
sir.
want to, is there a question? Okay. Okay. Another function, if I want to add two numbers, A and B, so def means I'm going to define a function. The name of this function is add function. It takes two inputs. Let's call them A and B in this case, colon. Now tab over whatever code you want. The result is equal to A plus B. This function didn't have to return a result. In this case, I want you to return this thing that I'm calling result. I want you to return the result, which is the sum. So now let's say A is equal to 5, B equals 6. The sum is variable is set equal to add functions. Put in these A and B's, feed them into the function. Whatever the result is, that gets put into this variable called the sum, and I'm going to print the sum. So
Professor?
Yes.
Professor, in other, like for example, C++, we have to declare the type of the function as well.
Yeah.
Here, if we were to put in like 2 strings or a double and a string,
Yeah.
would it just behave differently according to that, or would it give an error?
Yeah. Yeah. As long as you're, yeah, if you were to put in 2 strings, now you can be more careful. You can tell it what types of inputs you want, but I'm just touching things lightly here, right? So if you were to put, I haven't thought of that, but if you were to put in, say, A as some string A and some string B, then plus means concatenation, and it would return, I think, the concatenated string.
That makes sense. I was just curious about the different types, so I'll just try that out and see what happens.
Yeah. So what you can do, actually what you can do is you can say define add function, string A and string B, right? And then you could define this in different, you could, with using the same name, you could define what you wanted to do for different types of inputs. I mean, if that's useful to you.
Okay, just like how C++ treats functions. Okay.
Recursive functions. What recursive functions do is they call themselves. So let's take a look at this one. Define sum to x. Okay, the input is x, colon. The name is sum to df, means I'm defining this function, which is called sum to, which has the input x, colon. Now tab it over. Now you need a base case. If x is equal to, what I want is a function which sums the positive integers from 1 to x. So the base case, if I put in x is equal to 1, it should return 1. Else, I want you to return x plus sum to x minus 1. Right? Sum 2 of x is equal to x plus sum 2 of x minus 1. Okay? Now to tab over all the way to make sure that you're out of the function definition. Continue with your code. Okay, let's say num equals 6. I put in sum 2 of num. That sums the numbers from 1 to 6. And that should give me 21. And it does. Okay, so recursive functions call themselves. And you always need to define a base case. Okay. Lambda functions are kind of stripped ways of, for simple functions, you can sort of strip down all the formality. So here, what it says is cube is a lambda function, which takes an input x, and what it returns is x times x times x. For simple functions, name of the function equals lambda, what the input is, colon, what the output is. So print cube of 10, for example, should give me 1,000. I've done that. Okay. So, any questions? All right. I will.
Sir,
yeah.
I missed the starting of the lecture. तो ये इसमें आपने recording upload करनी?
Yeah. I will upload the recording on the YouTube channel, and I will put this. I will put this notebook on the on lms.lums.edu.pk.
Oh, okay, sir. Thank you, sir.
Okay.
Sir, I was able to access the Moodle.
You couldn't access the Moodle? Okay, I'll send the instructions for accessing the Moodle again. Okay.
Okay, sir. Thank you.
All right.
Also, sir, I haven't checked, but I might need a little help in setting up this Python on my PC.
Okay, so I will have Noman maybe do a help session, let's say on Saturday or something like that. Or anyway, I'll talk to Noman, and he's better at that sort of thing than I am. So we'll set something up. Okay.
Okay, sir.
Okay.
Thank you.
All right. Okay then. I will.
Sir, how to check that Python install on my computer is 3.0?
Oh, probably you should be able to, probably should be some command like which Python or something like that.
Professor, if I'm not wrong, if you just put Python in the command line, it shows you all the information.
Oh, okay. All right. Well, there you go.
Sir, how can I submit assignment on Jupyter Notebook? Do we need to additional editor as well?
Well, I mean, if you make everything on your Jupyter notebook, then I think you should be able to just send it as an attachment to me.
Links are only.
You should be able to send it as an attachment in an email, for example.
Okay.
Okay. All right. So I will talk to Naman about how we can discuss about how we can go about. Probably people need some help for how to set up a Python on a Windows box, right? So I'll ask him about how we should go about doing that. Okay.
And
right,
sir, do you have any office hours in this week or in the coming week?
Yeah. Well. Okay. I'll tell you by Friday about office hours. Okay.
Okay, so thank you.
All right. I will see everyone on Friday.